So, welcome. My name is Yoav Elad. I'm a product manager for databases at AWS. I work on Amazon RDS and Amazon Aurora. This session will be about Aurora. So first of all, let's do a little show of hands. How many of you have heard of this database? How many have used it? One. Okay. Two. Okay, so I'll try to make this a little bit of a combination of introducing the product and also a little bit of what's new for those of you who are already using it and would just like a little bit of information about what we did, let's say, in the last year. So first of all, Aurora is a managed database. So basically a database in the cloud that you can launch very easily with a few clicks. You go to the Amazon, to the AWS console. You say what kind of functionality you want. You choose a few options. You configure a few things, and you have a database launched. So you don't need to manage your database on your own, and that way it's an alternative to getting a server, like a compute instance like EC2, and installing your database server and configuring and setting up all the backups and monitoring and all of those things. I think fewer and fewer people are doing it these days. In these days of cloud, all you really want to do is, if you want something which is very standard, like a database, SQL, relational database, it's a super simple and common thing. So these kinds of services are available in the cloud now. There's no reason for you to go through all of the manual work of installing and maintaining and updating new versions and all of those things. It just does it for you. So Aurora runs under what's called Amazon Relational Database Service, which is what you see. Right now we're looking at the main page of the AWS console. From here you can select what kind of database you want. And as I said, set up a few options and you're done. You have a database running. Now you can, you can point your SQL client or your application to the database, and the database is running, and you can do your application development, testing, production, everything using that new database. So let's jump right into the console where we create a new database. So from the top, the main screen of the AWS console, you select RDS because Aurora runs under RDS, Relational Database Service. And this is our console for launching a new database. So the first thing I'll do is I'll go to create a new database. I'll show some of the options, and then I'll show you some options for a database that I've already created and some new stuff that came out. So the first thing I do is I select a database engine. I say which database I want. In this case, what we're going to select is Aurora. One of the main things that you need to know about Aurora is that it's compatible with open source databases. So two of them, MySQL and Postgres, which if any of you is using relational databases, you probably know that those are the main two open source relational databases that are common. So Aurora is completely compatible with your choice of either MySQL or Postgres, except that it's faster and it has more features. But if for any reason you just want a completely standard MySQL or Postgres database, you can also do that. So if I choose one of these options, I'll just get a completely standard open source database, just the one that was released by the open source community, but running obviously on AWS and managed for you. But if I choose Aurora, which is the selection we have now, then I get those extra features and higher performance. Okay? So a few things that I can choose here. First of all, like we said, we can choose MySQL or Postgres. Let's choose MySQL for our example. MySQL, the two versions that we support are 5.6 and 5.7, which are the most commonly used versions in the last few years. One of the next things I can choose is whether I want a regional or global deployment. This is actually a choice that you have to make for some of our older versions. If I choose the most recent one, and here I'm selecting the versions of the database, you'll see that for this one, this choice goes away. So the difference, but let's go back just in order to see it on the version I was looking at. A regional or global deployment, what that means is, do you want your database to run just in a single AWS region? So, I can run it in US East, Frankfurt, London, Paris, whatever. I can run it either in a single region, or I can say that I want a global database, which means that I have the master database where I read and write. I have it in a particular region, which I can choose. And in this case, we are in Northern Virginia, so US East, as you can see here. Or I can have it replicated to other regions of my choice. So what you would do, the reason you would want to do that is if you have either some application users that are located in other regions, you want all of the data to be replicated very quickly to those other regions, and you can have another copy of your application running in those other regions. You can replicate to up to 5 additional regions, which is a change. Actually, this came out last week that we increased the number to 5 regions. So if you know that you have a lot of users in Asia, in Europe, whatever, then you can put replicas of the database in those regions, and then they can get faster read performance. The other reason you might want to do that is for disaster recovery. So if for some reason the region goes down, I don't know if an AWS region has ever completely gone down, but let's say that there's problems, network problems, I don't know, whatever, then you can do a disaster recovery. You can say, I want that region, one of the other regions, which has very up-to-date information. It's usually up to the second. So I want that to be my new primary database, and you can continue working from there. So that's why you would want to do a global database. A few other options that I want to highlight. One of them is multiple writers, or what's known as multi-master. You can have 2 writers in the same region, so that both of them are essentially writing to the same storage. So you can point your application to either of those 2 writers, and they will both write to the same storage. You have to be a little bit careful, or to do some planning, so that you don't get too many conflicts. Like if both of the writers are writing to the same table, then one of them will succeed and one will fail, right? So, and we use a strategy of the first one wins. So if both of us are trying to write, or 2 writers are trying to write to the same, to the same record, the first one will succeed. The other one, the application will get a response that the write failed. And then the application can do whatever it wants. But the point is, you want to try to plan your application a little bit so that the writers write to different tables, for example, so that you don't get too many of those situations. Okay? One other option that I want to highlight here is called parallel query. So one of the main things that we changed in Aurora, and I said that it's compatible with MySQL and Postgres, right? So what did we change exactly? So the main thing that we changed was the storage layer of the database. So under the database, there's a very powerful storage system that we wrote completely from scratch at AWS, which stores your data in a very safe and durable way. Every time you write something, it writes 6 copies across 3 availability zones. So as you remember, in every AWS region, you have 3 availability zones, which are data centers which are located close to each other with low latency connections between them. And what we do is in each of those 3 availability zones, we write 2 copies of your data. So everything you write gets copied or gets stored 6 times. So first of all, there's not a lot of chance that, all those disks will fail and everything will, 6 copies is a lot. So your data is pretty durable and safe. The other thing about it is that there's an entire fleet of storage nodes that are doing all of these writes. So you write 6 times and I write 6 times to my own database, and between all of these different databases, there's lots of storage nodes that are shared between all of these instances and writing data. So what we did with this option, which is called parallel query, is to say, let's get those storage nodes to help in processing your queries. So you could have, like one database server, one compute instance, and lots of storage nodes, and those nodes are sitting right on top of your data. They're sitting right on top of the disks. So when you do a query, they're able to do some of the processing right there at the storage layer and only return a smaller amount of data to the to the database for processing, to finish the processing. So you get the power of lots of storage nodes working on your query in parallel, and then the database needs to do much less work so that the query finishes much faster. Okay, so this is an option you can enable when you start a database. Okay, a few other things that I want to highlight here. First of all, obviously, like almost anything in AWS, you can choose your instance size. So between our instances and in this case, in the case of Aurora, R and T family instances. I have a list, and I can choose, more CPU and memory, less CPU and memory, things like that. The biggest instance is called R524XL, which is somewhere here. Yeah, the last one. That's a pretty kind of, monster image, instance size. So if you have, if you have a really high number of reads and writes in your application, and you have a sort of scale-up architecture where you just need the biggest instance because you're just using one instance, then that's probably the one you would choose. Obviously, it's more expensive than the smaller instances. So you have lots of choices here in terms of which instance size. I'm not going to choose that one right now. Let's choose one of the smaller ones. More options that I would like to highlight. Multi-AZ. Remember that I just said that the storage, the data that you store is stored in several AZs, in 3 AZs. But for the server, for the database server that's running, you can choose if you want to run in 1 AZ or more than one. Usually you would also want to choose multi-AZ for the database instance. So that means that if the database if the database is slow or fails or crashes or anything like that, you would have another instance run, or if the availability zone has any kind of problem, you have a database running in another availability zone. I mean, the worst thing that can happen if I select a single availability zone is just that the database will be offline until it comes back up, right? You're not going to lose data because we said that the storage is always in multiple availability zones. But this is for the database instance if you want higher availability. Not that you should really have availability problems, but you should always plan for failure and for anything could happen in hardware and software. I'll skip a few things here. One thing that I do want to highlight, or maybe two things. One is backups. So like we said, this is a managed database service. One of the things it does for you is it manages backups. So what it does is basically every time you write something, every query that you that changes the database, it continuously backs it up to Amazon S3. So that's basically where we keep our backups, like a lot of things at AWS are stored in S3. You can do point-in-time recovery from those S3 backups. So you can basically go back to any point in time, down to every transaction that you made in the database, and you can restore the database back to that point from S3, which is simply an option in the console, right? So that gives you ability to recover from errors, to recover from all kinds of things that could happen. Another very interesting option is called Backtrack. If I turn this on, then I'm able to go back in time without even restoring from a backup. So Backtrack basically is a storage operation that simply moves my database back to the way it was at any point in time that I keep. And here I configure how many hours. You can see that I can enter the number of hours that I want Backtrack to keep of previous data. So, and then what you pay for is basically the storage that we need in order to keep all of that old data. So you can say, you want 72 hours, and we'll keep the last 72 hours of changes. Or you can have less or more, depending on how much you actually need. So if you make any kind of mistake, you drop a table by mistake, anything like that, you're running QA and you want to run a test and then you want to restore it back so that you can run the test again, things like that. So all you need to do is go to the console, or you can do it through a command, through CLI, and you can just move the database back to where it was at any previous point in time. It just takes a few seconds. It doesn't restore from a backup. It's just a storage operation inside of the database. And you can move back and forth. You can just position it at the point that you want. Okay? And then I think the last thing is monitoring. So there are several forms of monitoring for Aurora. The simplest one, which comes pretty much with every AWS service, is to use CloudWatch. If you're familiar with that, to just look at, basically hardware metrics like CPU, memory usage, things like that. A second option in Aurora is called enhanced monitoring, which was, where was it? So it's somewhere in the list. Was it down? Yeah, thank you. Enhanced monitoring gives you additional information that comes from the operating system about processes and things like that, which are running at the operating system level. And then the best one is called Performance Insights, which basically gives you database level information about performance. So it shows you, how many of your database connections or clients are waiting for CPU, how many of them are waiting for I/O, how many of them are waiting are waiting for different things that the database is doing, and it shows you the top SQL queries that are consuming resources in your database. So you see an ordered list, and you might be familiar with this with some other monitoring tools. It's a pretty common thing in database monitoring tools that you can see the top SQL queries, and you can see which one is doing a heavy operation, and you can try to resolve it based on that. Right? So these are the some of the options you get with Aurora. It's all built in. You can see that I'm just doing a few clicks. As soon as I create the database, from that point, it'll be completely managed. When there's a new version of MySQL or Postgres, it'll update to that version. I can define a maintenance window, so it'll do that, only on Sundays at 2 a.m. or something like that, and then it'll update. Okay. Two other things I wanted to mention that we released in the last 2 weeks that you might find interesting. One of them was actually released yesterday, which is called RDS Proxy. And that is a proxy that you can configure to sit in front of your database and do things like connection pooling, increase the availability. So if the database crashes for any reason, the proxy can still keep the connections to your application, and put in security rules and things like that. So with the proxy, you're able to increase the availability and the scalability of your database. There's already been some database proxies on the market. You might be familiar with some of them. We decided that this would be a nice feature to do together with RDS and Aurora, RDS meaning Relational Database Service. And again, with just a few clicks, it's completely managed. It runs on the instance sizes that we configure according to the load that you have on your actual database. So that's one thing that came out yesterday. Another one that came out a week ago, where I want to do a little demo for that in the time we have left, is called Aurora Machine Learning. So obviously machine learning is huge, and there's a zillion different machine learning services at AWS, which you probably have seen that we've been talking about them a lot. One of the things that have been a problem is, what if you have data in your relational database, like Aurora, and you want to run machine learning algorithms on that? How do you get the data from your relational database into the machine learning service, get it to run the algorithm, and return the results in an easy way? So that's been a problem for a lot of people, because you have to set up pipelines, and or you just run it offline. You just extract the data from your database to some desktop tool, and you run those algorithms, and then you need to upload the data back. And you probably would not do that very quickly. Like, it's something that happens offline. So what we wanted to do was to make it really easy for you to run machine learning algorithms on your database and on the data in your database. And what we did is we enabled those machine learning algorithms through SQL queries. So basically, all you need to do is in your SQL statement, you can say, I want to query for certain things and for the results of the machine learning algorithm that I specify. So let's do a very quick demo of that. So what I have is, what I have here is a MySQL workbench. So this is a database client that's pointing at one of my databases. And the machine learning algorithm that we're running here is sentiment analysis. So basically, with sentiment analysis, you take a piece of text, and it says whether the sentiment was positive or negative. So if I say, I really love Aurora, this is an amazing service, then the sentiment is probably positive, right? So this is using a machine learning service called Amazon Comprehend, which runs sentiment analysis. So what you see here is a few examples. Well, you don't see them yet. Let me run them. And there's 4 lines. There's 4 records in this table. Let me run this. And I think that there's a kind of a slow network connection right now for some reason. You should see it in a moment. And basically, what you can see here is that I'm running a SQL statement which says I'm selecting the comments from the table, and I'm running a SQL function called comprehend detect sentiment, and that's simply, in the background, it's making calls to the actual comprehend service and returning the results here. I think we're out of time, so I think we had some kind of network connectivity problem, but you get the idea. I actually wanted to show you an option to write. We could have changed the text right now and tried a few things that you might suggest, and let's see if it says it's positive or negative. But for some reason, we were not able to do this. So I think with this, we're out of time. So thanks a lot, and you can go to the RDS console and try it out, start a database, and hope it works for you. Thanks a lot.